Okay, main point 3, day 2, we're going to look at the unit circle. Okay, the unit circle is called the unit circle because the radius of the circle is 1 unit. The center of the circle is 0, 0. So right here in the middle is 0, 0, which is also normally where the vertex of our angle goes. I'm going to write a random ordered pair that is on this circle. Okay, just like in the previous section, if I draw the terminal side here and I drop an altitude and consider this angle theta, okay, because this is x and this is y, those are the two legs, and then the third side is the radius. Okay, I'm going to draw this little triangle over here. It's this, 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 because I want you to see where the ratios are coming from. This is theta. So I went to the side x, I went up y. Now, in the previous section, we said that this was the radius, but this is the unit circle. So the radius of the unit circle is 1. So this is going to be 1 here. Okay, now I'm going to write the trig ratios. So if I do the sine of theta, we learned in the last section that that is going to be y over r. So that's going to be y over 1, which means it's just 1. Or not 1, just y. And let's look at the cosine of theta. The cosine of theta would be x over r, but the r is just 1, so it's x over 1, which means the cosine is equal to the x coordinate. The tangent of theta is still y over x. Okay, so the reason the unit circle is so useful is because if I want the sine of theta, it is the y coordinate. If I want the cosine of theta, it is the x coordinate. And if I want the tangent of theta, I can use it by doing the y coordinate divided by the x coordinate. Okay, now before we use it, we're going to label some special angles on the unit circle just like we did before. So I'm going to label the radians in the ordered pairs. Let's do the radians first. We did them before. Okay, so remember, this is 0. What's this? Pi over 2. Pi. 1 pi over 2, 2 pi over 2. This is 3 pi over 2. Okay, now I'm going to label the other radians. Okay, if this is 0 and this is pi over 2, if I split it in half, this represents pi over 4. This is 1 pi over 4, 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4, which is 5. Now we're at 5 pi over 4. 6 pi over 4 is 3 pi over 2, and now we're at 7 pi over 4. And then if I keep going, I'm at 8 pi over 4, which is 2 pi, which means I've completed my full circle. So those are the radians. Now each of these ordered pairs each of these points also has an ordered pair. Okay, now some of them are easier to label. So let's look back up here at the unit circle. If this is a unit circle, then the radius of the circle is 1. So if I start from 0, 0, and I go to the right 1, that ordered pair is 1, 0. If I start from the origin, 0, 0, and I go up 1, that ordered pair is 0, 1. If I go from the origin, I go left 1, my ordered pair is negative 1, comma 0. If I start from the origin and I go down 1, my ordered pair is 0, negative 1. Those are the most important points on the unit circle. And you can always figure them out. Okay, now the last points are remaining are relating to pi over 4. So I'm going to switch to the second page so we can look at this special triangle to see how to label it. Okay, now I'm going to look at this one triangle right here. This is my right angle. This is pi over 4. Pi over 4 is like 45 degrees, which means that this is root 2 over 2, and this is root 2 over 2, which means this ordered pair here is root 2 over 2, comma root 2 over 2. And we're going to remember this fact soon. Okay, now I'm going to go to this point over here. Okay, if I draw a triangle here, this is still 45-degree angle, so it's going to follow the same pattern. But because I'm in quadrant 2, I'm going to go left. So my x-coordinate is going to be negative root 2 over 2. And then I'm going to go up, so that's going to be positive root 2 over 2. My x is negative, my y is positive. Okay, now if I go to this location over here, it does make a 45-degree angle, but it's down here. So I'm going to go left and I'm going to go down, which means my x-coordinate is negative and my y-coordinate is also negative. Okay, now I'm going to go to quadrant 1, 2, 3, 4. I'm going to go right, so my x is positive. I'm going to go down, so my y is negative. So this is going to be positive root 2 over 2, comma, negative root 2 over 2. Okay, now let's consider the second triangle. Okay, now pi over 4 was halfway between 0 and pi over 2, which is 0 and 90, so it represented the 45-degree angle. So this is 45-degree angle. Because this was a unit circle, this distance here was 1 because it's the unit circle. I'm going to figure out these two sides because this is my x and this is my y. Because this is isosceles, x and y are actually the same. So I'm going to write the equation x squared plus x squared equals 1 squared, which means 2x squared equals 1. If I divide it by 2, I get x squared equals 1/2. And then I'm going to square root both sides. So I get x equals 1 over root 2, and then I need to rationalize it, so I multiply by root 2, so I get root 2 over 2. So that's telling me that the x-coordinate is root 2 over 2, and then because it's isosceles, the y-coordinate is also root 2 over 2. So root 2 over 2, root 2 over 2. Okay, let's pause and go back to the unit circle. Okay, I'm going to label my radians first, so 0, pi over 2, pi, 3 pi over 2, and then I'm back to 2 pi over 2. Okay, now 0 to pi is getting divided into 1, 2, 3, 4, 5, 6 sections. So this is pi over 6. This is 2 pi over 6, which is pi over 3. 3 pi over 6, 4 pi over 6, which is 2 pi over 3. 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is 5 pi over 3. Are we on 10 pi over 6? 11 pi over 6. And then I'm back to 12 pi over 6, which is 2 pi, so I made my first circle. Okay, now let's label the easiest points first. This should say label the radian ordered pairs of the unit circle. So if this is a unit circle from here to here, I'm going to go right 1, which is going to give me 1, 0. From the origin, I'm going to go up 1, so this is going to be 0, 1. I'm going to go left 1, and then I'm going to go down 1. So those points are going to stay the same. Okay, now I'm going to consider each of these little triangles here, and let's look at just one of them, and then we're going to look at the special triangle. Okay, if I drop this down, I get that. This is, what is this? This is 90 degrees. It's divided into 1, 2, 3, which means this is 30 degrees. Okay, this is 30 degrees. The radius is 1, so the hypotenuse is 1. So let's look at this special triangle here. This is 30, 60, 90. Okay, because this is the unit circle, the radius is 1. Okay, now remember the pattern for this was, if this is 1, this is 1/2. Okay, and then the pattern was, if this is 1/2, this is 1/2 root 3, or we could do the Pythagorean theorem to figure it out. It is going to be 1/2 root 3. I'll do Pythagorean theorem to show you that it's true. What should we call this side? We're going to call this side y. No, not y, x, because it's going in the x direction, of course. Okay, so x squared plus 1/2 squared equals 1 squared. X squared plus 1/4 equals 1. Well, I want to minus the 1/4, but I need a common denominator. So 1 is actually 4 divided by 4. That makes sense. Let me minus 1/4. Okay, I'm going to go up because I'm out of room. X squared equals 4/4 minus 1/4 is 3/4. And then if I square root it, I get x equals, the square root of 3 is square root of 3. The square root of 4 is 2. So this sign is going to be square root 3 over 2, which is the same as if I had then this times root 3. Okay, so that means at this point down here, in the x direction I go root 3 over 2, in the y direction I go 1/2. So this point is root 3 over 2, comma 1/2. Okay, now let's consider the other quadrants. Okay, so this point is right root 3 over 2 up 1/2. This point over here looks the same level, except I went left and then I went up. So this is going to be negative root 3 over 2, comma 1/2. Okay, what other ones look the same size? This one looks the same size. I'm going to go right root 3 over 2, but I'm going to go down 1/2. And then when we're matching one down here, I'm going to go left root 3 over 2, and I'm going to go down 1/2. Okay, and then if you look at the circle, all the ones that have 6 in the denominator, they all have the same ordered pair with different signs. So if you know one of their ordered pairs, you can always get the others. Okay, now let's consider pi over 3. Okay, now pi over 3, let's draw a little line going here. This is a right angle. This whole angle right here, this is now 30 plus 30. This is a 60-degree angle, which means this is a 30-degree angle. So if I look back at that triangle that I drew, this is actually the same triangle, but now the 60 is on the bottom and the 30 is at the top, which means now this is on the bottom and this is the up. So my x is 1/2 and my y is root 3 over 2. Let's look and see if that makes sense. So 1/2 is the short distance, root 3 over 2 is the tall distance. So this ordered pair is 1/2 short distance, tall distance is root 3 over 2. Okay, since this is pi over 3, all the ones with a 3 in the denominator, which is this one, this one, this one, and this one, should have the same ordered pair with different signs. So if I go to this one, since I'm in quadrant 2, x is negative, y is positive. If I go to quadrant 3, x is negative, y is negative. If I go to quadrant 4, x is positive, y is negative. Okay, so now we've labeled this unit circle with all these special locations. We don't know how to use it yet, but we're going to learn that in the next class.